Alright, so from the work that we've done before, we know that in order to solve this problem, we really need to use some trig identities. And in particular, you can't really turn cosine into sine, but you could definitely replace sine squared with cosine squared and some other stuff. Okay, so if you recall, the first Pythagorean identity has something like this: cosine theta plus sine theta, cosine squared theta plus sine squared theta is equal to 1. So one of the ways that we could use this identity is simply just to rewrite it a little bit, and we can say that sine squared theta then must be equal to 1 minus cosine squared theta. Now let's think about why this is useful in this particular problem. So if I continue with this problem, cosine theta equals 1 minus 2. Now instead of saying sine squared theta, I am going to replace it with 1 minus cosine squared. So one of the reasons this problem is straightforwardly solvable now is because we have everything in terms of cosine. You have a cosine squared in there, but I think we know how to deal with that already from our previous work. So now we can say cosine theta is equal to 1 minus 2, so we're just distributing the 2, right, plus 2 cosine squared theta. And now we can rearrange things to make it look sort of like a quadratic. So we have 2 cosine squared theta, bringing the cosine over, so you get negative cosine theta, and then these two gives us negative 1. So we can proceed with a little bit of factoring. We can say 0 is equal to, and remember this here by substitution, I mean this is really like 2w squared minus w minus 1, right? So if we factor this, we get 2w plus 1 w minus 1. So, and then we can apply that to here. We can say this is 2 cosine theta plus 1 times cosine theta minus 1. Now separate them into two different pieces, so we get 0 equals 2 cosine theta plus 1, and 0 equals cosine theta minus 1. This is negative 1/2 is equal to cosine theta, and over here we get 1 is equal to cosine theta. Know your unit circles. So here is the unit circle, and cosine is equal to negative 1/2 right here and right there, and those 2 points are 2 pi over 3, and down here this is 4 pi over 3. Cosine is equal to 1 right here, and at that point theta is equal to 0. Okay. So our final solutions: theta is equal to 0, theta is equal to 2 pi over 3, and theta is equal to 4 pi over 3. Okay. So I went over that last part a little bit faster, just because I hope that by this point you've seen some examples of how to solve these quadratic trigonometric equations. What I wanted to focus more on is using the trig identity that we have at our disposal. So lots of stuff going on here in this section. You got trig identities, you got quadratics, you got factoring, you have to know the unit circle, and in some cases you even also have to know the different periods. So this section is where a lot of different stuff that you've learned in the past starts to really come together. If you have a hard time with this, it's important you pinpoint why it is that you have a hard time, which part of the things that I said did you have a hard time with, and ask for help on it. This is difficult for just about everybody. But as always, ask for help if you need it. Thank you for watching and have a wonderful day.